Welcome you all students. Our next topic is mass moment of inertia. So in order to understand this mass moment of inertia, I just going to have a body. Okay, this is the body, right? So here the body is with a mass m, capital M. Okay, and I just going to consider a small body. Okay, so it has an mass dm. It's with a small mass, so I just going to consider it as dm. Okay, so in order to understand the mass moment of inertia, we used to take the mass moment with respect to the axis. So here I just going to have an axis which I going to give as AA. Okay, so it is just a bit different from mass moment of inertia of an area. Okay, mass moment of inertia is bit different from moment of inertia of an area. In the moment of inertia of an area, we will get in terms of area. Here, instead of area, the mass will be. That is the change we're going to get here. I just going to take the measurement between the gap of the axis AA and this small body dm, which is R. It's our consideration. Okay, so here we just going to take the mass moment of inertia. Moment is nothing but force into perpendicular distance. Okay, so here the mass is the consideration. So mass moment of inertia, I can give mass moment of inertia about AA, which is equal to, instead of force it is mass, so dm into its perpendicular distance. Its perpendicular distance, it is taken about the axis A. Its perpendicular distance is R. It's a second moment, so d square. Sorry, it's a R square. Okay, I hope you get it. Moment of inertia of an area, we get dA into R square. Here in the dA we got dm into R square. That is the change. If you are going to take the moment of inertia, that means mass moment of inertia for whole body. Okay, the entire body. It's easy one. Just do the integration of this. The integration of dm into R square. Okay, you will get the entire mass moment of inertia. Okay, so and the important term here is unit. SI unit. It's an important one. When you come to the moment of inertia of an area, moment of inertia of an area, we get meter power 4. Okay, so here the unit is dm is a mass, so which is kg into R square. It's a distance. Okay, so distance in the sense meter, so here it is square, so meter square. Okay, kg meter square is for mass moment of inertia. So when you are working with the moment of inertia of an area, it's a meter power 4. So don't confuse with it. Moment of inertia of an area is meter power 4 and SI unit of mass moment of inertia is kg into meter square. Keep it in your mind. Let it be. And if you just look into the radius of gyration, of mass, we have learned radius of gyration for the area. If you are just doing for mass, it's a smaller change. Instead of area, we need to put mass. That's the difference. I is equal to k square into m. So here the same concept, just like radius of gyration of area, here comes for the mass. Okay, so here the radius of gyration is equal to root of I divided by m will be the the formula. Okay, so unit, just like radius of gyration for an area, here as well meter. Okay, it's a distance between the considered axis and the centroid of the body. Okay, so here it is just a distance, so it's a meter or centimeter or mm. And the parallel axis theorem, theorem for mass moment of inertia. Okay, right, fine. So here it also just like the previous one, moment of inertia for an area. Here instead of area, the mass will be substituted. So if you are considering a body, and just I am going to take, this is the central axis of x. Okay, so here if you put it, it will be y. So here I just going to consider an axis ahead from the body, which is with a distance h. Then I can say the parallel axis theorem about AA axis, AA is equal to sum of moment of inertia of that particular body about this axis, about this centroidal axis IXX. Okay, that body about IXX plus mass into product of product of the mass of the body into the distance between the centroidal axis and the considered line AA. Okay, so into h square. So here the difference we got in the parallel axis theorem for the mass moment of inertia is the mass alone. There, parallel axis theorem for the area, we get in the place of mass just an A. That's the difference going to make here. Okay, so I hope you understood. Let us move to the formula part. I have just displayed some of the basic shapes of solids. Okay, so here actually we know we are dealing with the mass moment of inertia. So mass moment of inertia is just for the 3D object. Okay, moment of inertia for an area which is just for a plane, that is for the 2 dimension. This mass moment of inertia, it's for a 3D object. Okay, just put it in your mind. So here I have basic shapes just like prism, sphere, cone and cylinders, right? So first let us begin with a prism. I have made an axis with respect to CG, center of gravity, X. This is Y and this is AZ. Okay, so here the formula of moment of inertia in terms of IXX, IYY and IZZ I have mentioned here. Okay, IXX, which is equal to mass divided by 12 into d square plus h square. D square in the sense it's width, and h is the height of the object. Similarly, y, for the y, moment of inertia, mass moment of inertia IYY, which is equal to m divided by 12 b square plus h square. B in the sense it's a length and h is the height of the object. And IZZ, m divided by 12 b square plus d square. Okay, for the z, b square plus d square. And mass of the prism, mass in the sense it's nothing but mass is nothing but volume of the object into density of the object. So here mass of the prism is nothing but mass of the prism. We can say first what about the volume? Volume is nothing but length into breadth into height of the object, right? B D into H. Again, if you multiply with a rho, we will get the mass of the prism. It's a simple, okay? Volume into rho. B D H into rho. We get the mass of the prism. And move for the sphere. Sphere, it is so easy. Ixx, Iyy and Izz about the centroidal axis, which is equal to 2 divided by 5 mass into radius square, or in the sense it's a radius of the sphere, okay, sphere radius. So that's what given here. And mass of the sphere, volume into rho, 4 by 3 pi r cube into rho. It's so easy. Volume of the sphere into rho, right? Fine. Move to the cone. Cone, here is the centroid. It's a center of gravity. About that, this is the x-axis, this is the y-axis, and this is the z-axis. So for the Ixx, which is equal to 3 divided by 12 m r square, r is the radius of the cone, plus 1 by 10 mass into h square. H is the height of the cone. So this is the height. So this is the height of the cone. Height of the cone. And if I take here, this would be the radius of the cone. Okay, fine. Iyy, which is equal to 3 by 20 mass into radius square plus 1 by 10 mass into h square. Okay, and Izz, which is equal to 3 by 10 mass into r square. Okay, and mass of the cone, volume into rho, right? So 1 by 3 pi r square into h, 1 by 3 pi r square into h is the volume, and into rho, multiply by rho, you will get the mass of the cone. And for the cylinder, I have taken the axis x, y, z through the CG, center of gravity, and Ixx, which is equal to mass divided by 12 into 3 r square plus h. R is nothing but it's a radius. It's the radius of the cylinder, and h is nothing but height of the cylinder. Okay, h is the height of the cylinder. Similarly, Iyy, which is equal to mass divided by 12 into 3 r square plus h square, the same likewise. And Izz, which is equal to mass into r square divided by 12. And the last one is mass of the cylinder, the same volume into pi. Volume of the cylinder, which is nothing but pi r square into h, right? Pi r square into h, again multiply with rho, we get the mass of the cylinder. Okay, so I hope you understood the concept of the mass moment of inertia. It is very easy. In the place of area, we just putting the mass. So when you compare the mass moment of inertia of an area and mass moment of inertia, which is just a bit difference. Instead of area, here it is mass. That is the difference. And the simple solid shape, I have displayed the formula. Just keep it in your mind. Here it is a 3D, okay, 3-dimension object. So we will have the mass moment of inertia in 3 axes: Ixx, Iyy and Izz. So I hope you understood. Thank you so much.